9.8 Applications of Solving Quadratics. All we're doing today, guys, is we're using what we've learned about solving quadratics and we're applying them to word problems. All right, so applications, here we go. Example 1. Some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for this object's height d at time t seconds after launch is, and then they give us the formula. We love when they give us the formula because that means all the stuff that we just read, like we don't really have to pay attention that much because they went ahead and gave us the formula, right? How long will it take the fireworks to reach the ground? I want to break this sentence, this question, into two parts. First of all, it's asking us how long, which you need to understand it means we find t, right? We find time, right? It says how long, so we find t. Then at the end, it says how long will it take the fireworks to reach the ground? Okay, well, when it says the fireworks are going to reach the ground, you need to understand that that means h is going to equal 0, right? The height from the ground is 0, so we use 0 for h. If you can understand those two things, this problem becomes quite simple. So what we're going to do is let's go ahead and let's take our equation here and let's write it out. We have negative 16t squared plus 80t, and this is equal to the height, right? But we know the height in this problem that we're looking for is 0. Okay, well, if it's equal to 0, I hope you know by now that we can put this in calculator. So we're going to put this in y equals. We're going to look at the graph. Here we go. Y equals, and you guys can see I already typed it in there. Now, please notice I did not use t, I just used x, right? It's just a variable. Doesn't really matter what you call it. Now, I'm going to graph this thing. Let's see here. If we graph it the way you guys have it, it'll probably turn out like this. All right, so you can't even see the top of it, which isn't that big a deal because we want to know when it hits the ground. Well, it started right here at the ground. It went up and up and up and up and up, and then it came down here and then hit the ground again. So it's on the ground right here, so we need to know the time. Well, the time is just 1, 2, 3, 4, 5 seconds. Now, we always have to check our table and make sure that it's actually 5 seconds. So let's go to our table. Is 5, 0? Yep, right there. All right, do we see that? We do have a point at 5, 0. So in this case, right, we can sketch it here. Sketch it, it goes up like this. And that point is at 5, 0. So we're going to say 5 seconds till it reaches the ground. Now I will warn you, it doesn't always work out beautifully like this with my calculator. All right, but when it does, you're done. Like, don't make it harder than you have to. If it were me, I would always try to put it in my calculator first. Let's look at example 2. Here we go. A penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation, yay, they give us an equation again. Okay, how long, okay, so again, how long, right? That means we find the time, find t, would it take for the penny to strike a 6-foot tall person? Remember previously when it said reach the ground, so we knew h was 0? This is going to strike a 6-foot tall person. We're going to assume it's going to hit him right on the head, so we're going to say that h has to be equal to 6. You kind of follow me there? So let's go ahead and let's set up our formula. Let's set up our equation. We don't know t, so we're keeping t, negative 16t squared plus 1250 equals h, right? And so the height that I was given was 6. Well, this does not look like what we're used to, right? We kind of love it when it's equal to 0 because we can use our calculator. So let's go ahead and just get what we need. Let's subtract 6 from both sides. You can subtract it from this number because they're both just constants. And so I get negative 16t squared plus 1250 minus 6 is going to be 1244. And this is equal to 0. Okay, now I'm going to use my calculator because if my calculator can answer this for me, it totally should because that's awesome. So we have 1244. No x though, right? This does not have t on it. Let's take a look at my graph. Here we go. Okay, so we're looking at this point right here. It looks like it's about, looks like maybe it's 9. Let's check my table. No. Look, 8, it's still at 220 feet high, and at 9, it's negative 52 feet high. So my graph, like it's not hitting right at 9, which means I have to solve this by hand. Guys, if you have to solve it by hand and it's equal to 0, I would recommend using the quadratic formula. Okay, so we're going to use the quadratic formula here to solve. Let's quickly kind of write down my numbers here. We know the number with x squared is a, or in this case t squared, so we're using negative 16. There's no number with just x or just t, so we use 0 for that. And then finally c is 1, 2, 4, 4. All right, so all we got to do here is plug these numbers in. Here we go. First things first, we have negative b. Okay, so my b value here is 0, and I have it again right there. So we have negative 0 plus or minus the square root of 0 squared, that's a 2, minus 4 times a. Let's see, what is a? A is, well, hang on. A is 1, 2, 4, 4. All right, and we use it right there and also right here on the bottom. I'll put a little dot right here to get ready. Or no, I don't have to do that. Having problems. All right, all of this here, we got A right in here, which is 1244. Kind of a huge number, times, oh man, you guys, I messed up. I'm trying to rush. It's not working very well. A is negative 16, not 1244. Hopefully you caught that. Hopefully I didn't mess you up. Negative 16, and then C is 1244. All right, so my C value, and I only have to use it once, is just 1244. All right, all over 2A, right? So we got 2 times A, which is negative 16. All right, so let's clean this up. We have x equals negative 0, which is nothing. I don't need to write that, plus or minus the square root of some number, all over negative 32. So let's go ahead and let's figure out what numbers are under that square root. So I'm going to start, right? I'm starting right here with the parentheses. So 0 squared minus 4 times a, which is negative 16. And then b, which is 1244. And what number do we get? 7916. So 79616. Okay, so let's see if that's a nice number. What is the square root of 79616? Ooh, that's not very nice. Okay, that's not a super nice number. Well, let's go ahead and let's figure out my answer here. I do want a decimal because I kind of want, I know it's almost 9, so let's take a look what this is. I'm going to first use a positive 79616 over negative 32. Okay, and then I'm going to have a separate answer where I do a negative, right? That's that whole plus or minus idea. I just broke this up into a plus or a minus. 79616 over negative 32. And now we can type these in my calculator. So watch carefully. I'm going to do this one on the left here. I'm going to do this one first. Okay, so I've got a positive square root of 79616. And then click out of there, and then divided by negative 32. And I get negative 8.82. Now, on the right side, okay, this one right here, I'm going to type in the same thing I just did. Watch, I can click second entry, and all I got to do is make the front of this thing negative. So second insert and negative. And if you guys don't know how to use a calculator doing what I'm doing, like you can type it in again. All right, my new answer is a positive 8.82. Okay, you only want to use the positive, right? So we're going to say no negative time. That does not make sense, right? We do not want this answer. We only want the positive answer. So 8.82. You know what I should put on here? 8.82 seconds. That's how long it took for that penny to hit that guy. Okay? 8.82 seconds. So to sum up this problem, if your calculator can't give it to you, All right, can it give you a nice answer? Then use the quadratic formula, plug in A, B, C. Be careful, don't mess up like I did, and simplify. All right, usually we would tell you to leave it with the square root, but in this case, since I wanted an actual amount of time, I think a decimal approximation is okay. All right, last problem. Now this problem is a review from Unit 8. We are talking about the applications of quadratics. Actually, it might be Unit 7. We are supposed to find the maximum height of a roller coaster. Okay, it's talking about Apollo's chariot, a roller coaster at Busch Gardens. It says it moves at 110 feet per second. The equation can be modeled by h equals, and then we got all that. What is the maximum height? So you guys hopefully know that the first thing I'm going to do is I'm going to try and put it in my calculator. So I've already got negative 16x squared in there. I'm going to do plus 101x plus 10. And I'm going to look at my graph. Okay, well, I want to be able to see the highest point, right? Because it's asking for the maximum height. So I'm going to mess with my window. Let's try 150. Oh, that was negative 10. Should not mess with that. I want it to go all the way up to 150, so we can change the y max to 150. So 150, let's see if that works. No, I can't quite see it. I need to go a little bit higher. So a little bit higher than 150. Why don't we try why don't we just go 200? Okay, let's graph. All right, there is that maximum height. So it says, what is the maximum height? So we need to figure out this maximum. I'm going to draw a quick picture over here. Okay, and I'm going to say we need to figure out this right here is the maximum, and it's also the vertex. All right, it's also the vertex. So we're going to find this vertex, and we're going to do it by hand, all right, because I'm going to go ahead and tell you it's not a super easy answer to find. So we need to find the x-coordinate of the vertex, and I hope you guys remember that we do that using the axis of symmetry. Remember this negative b over 2a? This gives us the x of the vertex. So here we go. The b, in this case, is 101. So negative 101 over 2 times a, which is negative 16. So the x of my vertex is, let's see here, we have negative 101 divided by 2 times negative 16. All right, so we're getting x is 3.1, I'm just going to say 16. Okay, I'm going to round. Okay, so my vertex over here, we know the x is 3.16 something. We don't know the height yet. And that's what it's asking us for. It's asking us for the height. So what we do is plug in for x. So we're going to plug it into the equation for x. So we know the height is equal to negative 16 t squared plus 101t plus 10. Now I said plug it in for x. In this case, x, we're using t's instead of x's. So we're plugging in 3.16 for each of those. And that's going to give us the height. All right, all I got to do is type this big old thing in my calculator. So here we go. We got negative 16. And then we got 3.16 squared, close parentheses, plus 101 times 3.16. And then we got a plus 10 over there on the end. And we get 169.39. So our maximum height reached by this ride is 169.39. Again, y'all, this was kind of an old topic, finding the minimum or the maximum, but we definitely need to remember how to do that. So 169.39 feet high. Okay? All right, again, solve these with your calculator if you can. If not, use the quadratic formula. And don't forget that there are other things we can find in quadratics besides the zeros, right? Things like maximum, minimum, and all that good stuff.